Welcome to Circuit Secrets. In today's video, we're going to learn to use the si5351 to build an RF signal generator. This is our next stop on our way to creating a VFO to convert a 6-channel CB radio into a 40-channel. The si5351 is a clock generator that has a frequency range of around 8 kHz to 160 MHz. This makes it the perfect component for building signal generators and VFOs. A VFO is a variable frequency oscillator. The si5351 can be used as a direct replacement for crystal oscillators. A crystal oscillator is a fixed oscillator that generates a fixed frequency signal. The si5351 operates on the I2C bus, so it is a perfect device for learning more about I2C on the Raspberry Pi Pico. There is a handy library available for the si5351 that we will be using called EtherKit. The library uses the wire function to communicate with the si5351, and it cannot be changed to wire 1 without modifying the library. So this time we will be using wire instead of wire 1, which we used for the display in the previous video. We will still be using the display connected to wire 1, the I2C bus 2, for this demonstration, to show that both buses can be used at the same time. This is how we will wire the si5351 to the Raspberry Pi Pico. To work with the si5351, first we have to include the EtherKit library. If you do not have it installed, you can find it under Sketch, Include Library, Library Manager. Simply type EtherKit and you should see the library. Install it and you are ready to go. If you do not see it listed, you may need to update the Arduino IDE. If it is installed correctly, you will have access to new example sketches under the heading EtherKit si5351. Now we are ready to code. Starting with the display sketch, first we pull in the si5351 library from the EtherKit. Now we create an instance of si5351 and call it si5351. Next, we need to add our pin settings for I2C port 0 in setup. We use wire set SDA and wire set SCL to accomplish this. We set the SDA pin to 20 and the SCL pin to 21. Next, we make some changes to the display channel and frequency function. I would have created a separate function to output the signal, but there was already a switch set up that I could use to set the frequency. If I were doing a free band VFO, I would separate the two and use the frequency data to create the text for the display. First, inside the function, we create a variable to hold the frequency called VFO frequency. This variable has to be of the type unsigned long. This is specified by the library. In the cases for the switch, we set the VFO frequency variable to the appropriate frequency that corresponds with the channel setting. After the switch, we initialize the si5351. The init command takes the oscillator load, reference frequency, and correction value. The correction value is used for calibration. Calibration is necessary because of variations in the built-in reference oscillator. We will get back to that later. Our last new line of code is a call to the si5351 to set frequency. We pass it the VFO frequency variable multiplied by 100 unsigned long. We have to specify it as an unsigned long per the requirements of the library. We multiply by 100 because the si5351 takes the frequency at a precision of hundredths of hertz. So instead of taking 27 followed by 6 zeros to represent 27 megahertz, it needs to see 27 followed by 8 zeros. The last argument is to tell it which clock output to use, in this case clock 0. I connected everything together, uploaded the program, and the results were, well, not exact. The oscillator was far enough off calibration to show up even on my cheap frequency counter. Here is how I connected the frequency counter. So I decided to play with the calibration factor to see if I could get the results closer. I started with the example code that came with the EtherKit called Calibration. I connected my frequency counter as shown and tested the sketch. I used the correction value I came up with by running the calibration sketch and attempted using it in my sketch. It was closer, but still not good enough. I changed the value hard-coded into the sketch and re-uploaded it a few times until I had these results. It is now a working and fairly well-calibrated signal generator. In the loop, I can change the way display channel and frequency is called to generate a signal for calibrating a CB radio receiver. All it takes is commenting out the incrementing of the channel and setting the channel to the center of the band, say channel 20. So there it is, a working signal generator, and we are one step closer to a working CB radio VFO. In an upcoming video, we will deal with frequency offsets for mixing, transmit, and receive. If you enjoyed this video, please don't forget to like and subscribe.